So I begin with the chapter atoms. So you know the basic idea about atom. In our syllabus we have to learn about hydrogen atom. Understood?
Okay.
We have to learn about hydrogen atom. Hydrogen atom will have a nucleus. Hydrogen atom contains only one proton, correct? Hydrogen atom contains only a single proton in the nucleus. Is it correct?
Yes, sir.
Single proton will be there in the nucleus. The charge of the proton plus E, correct? Charge of the proton is plus E. What is this? This is actually the nucleus of the hydrogen atom containing only a single proton having charge plus E. And there are plenty of orbits. Understood? Clear? There are orbits. The orbit numbers are n equal to 1, n equal to 2, n equal to 3, 4, 5, 6, etc. There is only single electron, but the electron will be appeared on one of the orbits at a time. Clear?
Okay, sir.
The electron will be staying on one of the orbit at a given time. The hydrogen atom has only a single electron, but there are various orbits or energy states. Understood? There are various energy states. At normal temperature, normal temperature, the electron will be there in the first energy state, first orbits. Clear? The electron will be revolving around the nucleus in the first orbit in the normal temperature. In the higher temperature, if the electron acquire more energy, it will go to the other energy states. Understood?
Yes, sir. Got it, sir.
So n equal to 1 is the ground state. Is said to be n equal to 1 is said to be the ground state.
Ground state. Yeah.
Okay. The next is, look at this. The energy, there are plenty of formulas in this chapter, atoms. Every formula you have to learn in the class itself. Potential energy, kinetic energy, and total energy of revolving electron. Okay. There is, that this is the structure of the hydrogen atom. The center one is the it's a nucleus. There is a single proton there plus E. The electron will be revolving in one of the orbit. Clear? Electron will be revolving around the nucleus in one of the orbit. Maybe n equal to 1 or maybe n equal to 2, that we don't know. It will have some radius, correct? Understood? There will be some radius. So this formula, you will learn another formula, but this formula is required if the radius is given. If this radius is given, you have to use this formula. But there are cases in which the radius will not be given. The orbit number will be given. In that case, we will use another formula. So if the radius of the orbiting electron is given, we must use this formula. Okay? Radius of the orbiting electron is given, then we have to use this formula. These are about energies of the revolving electron. Understood?
Yes, sir.
The revolving electron will have certain energy, right? Clear?
Yes. Yes, sir.
Yes, it will have energy. What kind of energy does it have? It will have potential energy, correct?
Yes, sir.
The proof we don't need proof, just memorize the formula. The potential energy means the energy due to the position of the electron there. Clear? Understood?
Yes.
The energy of the electron due to its position. That's all. Potential energy of the revolving electron will be minus E square by 4 pi epsilon 0 R. Just memorize that. Negative sign is there. Please note it. And since it is moving, the electron is not stationary. It is moving actually. Moving with some velocity v. Suppose the mass of the electron is m. Understood? Clear? Is it okay? Clear? The mass of the moving electron is m. Suppose it is moving with the velocity v. If both m and v are available, The kinetic energy has a formula half mv square. You studied already, clear, in the other chapters. The moving electron will have not only have potential energy, it also has the another energy, kinetic energy. Energy due to motion, clear? Hello? Energy due to the motion. The kinetic energy is, there are two formulas. One is half mv square.
Okay.
Another formula is E square by 8 pi epsilon 0 r. You need to memorize this formula. Remember that this formula can be used only if the radius is given in the question. Clear?
Yes, sir.
The moving electron has two type of energy, potential energy and kinetic energy. So the total energy of this revolving electron will be, total energy will be potential energy plus kinetic energy. Potential energy plus kinetic energy, just adding this one and this one. Proof I don't want to explain. Adding these two, you will get minus E square by 8 pi epsilon 0 r. Okay, clear? So in short form, at least memorize this. At least memorize what?
These formulas, sir.
This formula. I think you better memorize. Okay, even if I give a separate formula, you will not remember that. I think you better memorize all these three formula. Okay, clear? I think that is much better. Potential energy, kinetic energy, total energy. Let me discuss this. I don't want to write it again. I don't want to delete it. To save time, let the solution be there. I will explain each lines. Okay, I will explain each lines so that I can save time.
Okay, sir.
So let me read the question. The ground state energy of the hydrogen atom is minus 13.6 electron volt. The ground state or energy of the hydrogen atom is this. What are the kinetic and potential energy of the electron in this state? That's a question. Okay.
Okay, sir.
The ground state, okay, that is the first orbit. The electron is revolving in the first orbit. Okay, the diagram is not required for that for now. The energy, the total energy of the electron is this one. Understood? Clear?
Yes, sir.
The ground state energy. Energy means total energy. Clear? The total energy of the electron, revolving electron, is given to us. That is written here. Total energy of the revolving electron is minus 13.6 electron volt. Clear?
Okay, sir.
This step is okay? Clear?
Yes, sir.
Now, what is our question? We have to find out kinetic energy and potential energy. Understood?
Yes, sir.
The total energy is given. We have to separately find out potential energy and kinetic energy. We have a formula that total energy has the formula, you studied that, minus E square by 4 pi epsilon 0 r. Clear?
Yes, sir.
Just 1 minute. So, total energy equal to minus 13.6 electron volt. Are you clear this step?
Yes, sir.
What is the formula of total energy? Total energy has the formula minus E square by 8 pi epsilon 0 r. Understood?
Yes, sir.
We studied that. All the three formula I have already discussed. The total energy of the revolving electron minus E square by 8 pi epsilon 0 r, that is given minus 13.6 electron volt. Clear? Hello?
Yes, sir.
I have just written the formula. Okay, that's all.
Okay, sir.
So can I delete the negative sign both sides in this equation? Yes, if I delete negative side in the left side, I have to delete the same in the right side. So negative sign deleted both sides. I get E square by 8 pi epsilon 0 r equal to 13.6 electron volt. Clear?
Yes, sir.
Now, I want kinetic energy. The kinetic energy has the formula E square by 8 pi epsilon 0 r. Clear? Hello.
Yes, sir.
We studied that. I think you have not studied yet. You better study today itself. The kinetic energy has the formula E square by 8 pi epsilon 0 r. E square by 8 pi epsilon 0 r, we have already got it. Clear? E square by 8 pi epsilon 0 r value, I have already got it. 13.6. So that is actually kinetic energy. This one is actually the formula of kinetic energy. So kinetic energy equal to E square by 8 pi epsilon 0 r, which is 13.6 electron volt. Clear?
Yes, sir.
You please read till this step. Okay? Please read till this step. After that I will discuss the next step. Okay? Now I want not only kinetic energy, I want the potential energy of the revolving electron. The formula is required. Without formula, you will not be able to solve. Potential energy is minus E square by 4 pi epsilon 0 r. Understood? Clear? Correct?
Yes, yes, sir. Yes.
There is a formula. We studied that. Okay. U equal to minus E square by 4 pi epsilon 0 r. We know the value of E square by 8 pi epsilon 0 r. So here, look at this formula. Can I write? You can see 1 by 4 here. Is it correct? Can you see 1 by 4 here? 1 by 4 can be written as 2 by 8. Is that okay? You can see a 1 by 4 here, or 4 in the denominator side. 4 in the denominator side. Can I write it as like 2 by 8? If I write 2 by 8, the 2 will be cancelled. You will get 4 in the denominator side. Is that okay?
Yes, sir.
2, 8 will be cancelled. You will get 4. So this expression can be written as 2 times minus E square by 8 pi epsilon 0 r. Is that okay?
Yes, sir.
Why I split like this? Why I write like this? Because E square by 8 pi epsilon 0 r we know. That's why the 4 is written as 2 by 8. So 2 times minus E square by 8 pi epsilon 0 r. We have studied that. We have already found it. Minus E square by 8 pi epsilon 0 r is actually minus 13.6. So this expression is what? This is actually minus 13.6 written. 2 into minus 13.6 will be minus 27.2. Okay?
Yes, sir.
The next is regarding the energy. Energy we have studied right now. We have studied the energy right now. Then there is another formula for finding energy of the revolving electron. You know, the electron is revolving around the nucleus in a hydrogen atom. If the radius is not available, if the radius is given, we have a formula E minus E square by 8 pi epsilon 0 r. But in some questions the radius will not be given. Instead of that, the orbit number will be given, like n equal to 1, n equal to 2, n equal to 3, like that. The orbit number will be given. Then the total energy. Total energy is usually denoted by En. In this particular case, let me denote by En. Total energy, if the electron is revolving in the nth orbit. If the electron is there which is revolving in nth orbit, its total energy will be, remember, total energy will be minus 13.6 by n square electron volt. Clear? Understood? Please memorize this. So if radius is given, minus E square by 8 pi epsilon 0 r. But if orbit number is given, radius is not available, but orbit number is available, the total energy is obtained by using this formula. Clear? Next is, there are so many formulas. You need to learn today itself. Don't delay. Don't make any delay.
Got it.
Next is radius, speed of an electron in the nth orbit, nth energy state or nth orbit. You know that there is a nucleus. In the case of hydrogen atom, there is a nucleus. there are various energy states, n equal to 1, n equal to 2, n equal to 3, like that. The electron will be on one of the orbit at a given time, one of the orbit. So the what is this? This is said to be the ground state, correct? Clear?
Okay, sir.
This is said to be the ground state. If the electron is said to be, if the electron is in the ground state, the orbit number is 1. Orbit number is 1. So the radius of the electron in the first energy state, the radius of the electron in the first energy state, denoted by R1. Okay, clear? Hello?
Yes, sir.
R1 is the radius of the circle, the first circle, radius of the first circle, that's all. It is denoted by R1. That value you must memorize. That value, it is very very important, you must memorize that without any proof. The radius of the first energy state, R1, is equal to 0.53 angstrom. 0.53 angstrom, or 0.53 into 10 raised to minus 10 meter. Because angstrom is 10 raised to minus 10 meter. You need to
So after this, can you teach atom or nuclear lesson also, sir?
So R1 equal to 0.53 angstrom, and remember the electron is moving in the first energy state. The velocity v1, the velocity of the electron v1 is 2.2 into 10 raised to 6 meter per second. This value also you have to memorize. v1 is the velocity of the electron moving in the first energy state. 2.2 into 10 raised to 6 meter per second. Then using these values I can find out the radius and velocity of the electron in any energy state. Rn equal to radius of the nth orbit. Clear? Rn is what? What is Rn? Rn is the radius of the nth energy state or nth orbit.
Okay, sir.
Vn is the velocity of the electron in the nth orbit. In the nth orbit, the electron will have a certain velocity, Vn. This formula you better memorize. Rn equal to n square R1. R1 value we have already studied. So nth orbit, the radius of the nth orbit is given by n square into R1. Memorize the formula. And velocity of the electron in the nth orbit. In every orbit the electron will be moving. So velocity of the electron in the nth orbit will be v1 by n. Okay, v1 by n. Memorize this value formula. This is a simple question, but to make you understand the formula, I must discuss one question. The radius of the innermost electron orbit. It's actually a simple question, but in NEET exam you need not worry. Actually, most of the questions will be like this. The direct problems they are asking. Most of the question. Okay.
Okay.
The radius of the innermost electron orbit of the hydrogen atom is this. I think that from this chapter only normally average level or easy question will be asked. Okay, from this chapter. The radius of the innermost electron orbit of the hydrogen atom is this, given to us. What are the radii of n equal to 2 and n equal to 3 orbits?
Okay.
So R1 is given in the question. Clear?
Okay, sir.
R1 is what? R1 is the
5.2
given. R1
into 10 to the power
yeah.
minus 7.
Yes. R1 is the radius of the electron which is moving in the first energy state. Clear? The radius of the electron moving in the first orbit. That is R1. Given. Clear?
Yes, sir.
R1 is given. If R1 is not given, you have to use this value. I have already told you that you need to memorize this.
0.5
Angstrom. Yes. If it is not given, R1 is not given, you have to use this value. Here R1 is given, so we need not worry about that. R1 is given to us. We have to find out the radius of the second energy state and third energy state. Clear? The diagram is not required. Have you understood the question? Clear? N equal to 1 will have certain radius, right?
Yes, sir.
N equal to 2 will have certain radius. Like that. Understood? Clear? Diagram is not needed. So the radius of the second energy state or second orbit, that is R2 and R3 is our question. Clear?
Yes, sir.
R2 and R3 is our question.
Yes, sir.
We have a formula Rn equal to n square into R1. Clear?
Yes, sir.
Rn equal to n square into R1. I want to use this formula. So substituting n equal to 2 in both the left side and right side, put n equal to 2. R2 equal to 2 square into R1. R2 equal to 2 square into R1, that is 4 into R1 is given to us. Clear?
Yes, sir.
So 4 into R1. Calculation I don't want to discuss. So multiplication gives you the value 21.2 into 10 raised to minus 11 meter. Clear?
Yes, sir.
Rn equal to n square into R1. This formula is used.
Yes.
Then R3 we have to find out. Third orbit, how much radius? How much radius for third orbit? R3 equal to 3 square into R1. Clear?
Yes, sir.
That is 9 into R1. 9 into R1 will be this value. Clear? Next is energy levels. Next is what? Energy levels. We have studied the formula for nth energy state. If the
N
electron
is equal to minus,
Ah.
is equal to minus 13.6 by
n square electron volt. N stands for the orbit number. Clear? N stands for the orbit number. So this value, this diagram you need not memorize. Okay, just for understanding. Just for understanding I am explaining this page. Actually this diagram is not at all required, but for the conceptual clarity, I am discussing this. Okay.
Got it, sir.
So you know that as the electron has a freedom in moving from one orbit to another orbit. Electron can jump from one energy state to another energy state. Understood? Clear?
Yes, yes.
Electron will jump from one energy state to another energy state if it gain energy or loses energy.
Okay.
Two things, one of the things can happen. Either electron can gain energy or it can lose energy. If the electron can gain energy if the radiation is falling upon this. Understood? Clear?
Yes.
Clear. If some radiation is falling upon this electron, the electron gains some energy. If the electron gain energy, what happens? It will jump to the higher energy state or higher orbits. Clear? Understood?
Yes, sir.
This happens, electron will jump to higher energy level when the radiation, if it absorb radiation. Clear? Understood? If it absorb radiation, because when the electron absorb radiation, what happens? Its energy will be increased, right? Clear?
Yes.
Okay. So now listen. So I'm talking about different energy levels. When n equal to 1, what happens? If n equal to 1, what is the energy of the electron? Substitute n equal to 1 in this formula. Clear?
Yes, sir.
If n equal to 1, the revolving electron will have certain energy. If n equal to 1, the energy will be, put n equal to 1 in this formula, you will get minus 13.6. This value you better okay, no problem, you need not memorize this formula. You have to memorize this formula. You have to memorize. When n equal to 1, in the ground state, the electron will have the energy minus 13.6 electron volt. Clear?
Okay, sir.
I told you this diagram you need not memorize. For the conceptual clarity I am discussing.
Okay, sir.
When
So
n
I
equal,
have to memorize the values of minus 13.6.
no need. Only thing is this formula you have to memorize. Understood? Clear?
Okay, okay.
When n equal to 2, what is the energy level? In question, suppose they are asking for that. In n equal to 2, what is the energy level of the electron? You have to put n equal to 2 in this formula. Clear? you will get the value as minus 3.4 electron volt. So in this way you can find the energy of the electron at different orbits. Clear?
Got it.
And remember, okay, that part is clear. So n equal to 2 onwards, the orbit number starting from n equal to 2 onwards, it is said to be excited states. Clear?
Yes.
N equal to 2, n equal to 3, etc., etc., they are said to be excited states.
Yes.
Okay, so no need to draw this. You place. Then let me discuss one important formula. Listen, this theory is not so important. Okay, this theory is actually, this is the derivation part. Let us skip the derivation part. Okay, clear?
Okay.
This part, this entire part is what? This is simply some derivation part. Let me skip it. I want to explain this formula written inside the box. Clear?
Okay.
I want to explain only this formula written inside the box. What I am saying is, listen, can you see this picture? Suppose, look at this. 1 minute. 1 minute. Now, look at this. Suppose the electron is currently in the higher energy state. Can you see that? Clear?
Yes, sir.
The electron is in some energy state, say n equal to 1. N1. We'll give some name for that. Electron has high energy now. Clear? As the electron moving outwards, its energy actually increases. If the electron staying in the outermost orbits, it has high energy.
Yes.
So initially the electron has high energy. Understood? Clear?
Yes, sir.
This electron can go to the lower energy states. Clear? The electron jump from higher energy state to lower energy state. Is that okay? Clear?
Yes. Yes.
The electron has freedom in jumping from high energy state to low energy state. Is that okay?
Yes.
As per energy conservation rule, if the electron jumping from higher energy state to lower energy state, it will emit some radiation. Understood? Clear?
Yes. Yes, sir.
The derivation part, I am completely avoiding the derivation part because it is not required for the time being. Remember the fact, if the electron is jumping from higher energy state to low energy state, what happens? A photon or radiation will be emitted. Understood? Clear?
Yes.
A single photon or radiation will be emitted. The photon will have certain frequency mu. Understood? Clear? The emitted photon will have certain frequency mu. The energy of the photon, the emitted photon will have an energy which is h into mu. H is the Planck's constant. Okay?
Okay, sir.
Planck's constant we have already studied. 6.63 into 10 raised to minus 34 joule second. Okay?
Yes, sir.
So the photon will have an frequency mu. So the emitted photon will have an energy h mu. Okay? H mu. It is equal to 13.6 into
By
1 by n2 square minus n1 square. Clear?
got it.
Okay. So this please read, except the derivation, you please read this one. Okay?
Okay. Yes. Yes.
Then one more thing I would like to discuss, problem I will discuss in the next class. This is about, I told you that initially the electron is in the higher energy state, correct?
Yes, sir.
Now it is going to jump to lower energy state. Is it correct?
Yes, sir.
What happens? Then a photon will be emitted. Clear?
Yes.
A photon. Clear? Photon will be emitted. The photon will have not only frequency, it will have wavelength also. Clear? Understood?
Yes, sir.
The photon is actually radiation. The radiation will have not only frequency but also it has wavelength. You agree with me? Clear?
Yes, sir.
mu frequency we can find out using this formula h mu. Clear? For finding frequency we have a formula h mu equal to this one. For if the question is about wavelength, we prefer this formula 1 by lambda equal to, what is lambda? Lambda is the wavelength of the emitted photon. Clear?
Yes.
1 by lambda equal to r into 1 by n2 square minus 1 by n1 square. You need to memorize this formula. Okay? Read this formula again and again. You will learn it ultimately. Okay?
Okay.
1 by lambda equal to r into 1 by n2 square minus 1 by n1 square. R is a constant, 1.09 into 10 raised to 7. Okay?
Got it.
Please read it.